Hi, welcome to another video on my Arduino Mega2560 and quite some electronics, including fischertechnik motors with propellers and a chain. Last time I dived into pulse width modulation and found that things are not according to my liking, and found quite high frequencies, but also I found that some other things were playing up. The point is that these motors, fischertechnik motors, have a frequency that is in the range of 40 Hz to 120 Hz, and that is something that matters with these motors. So when I measure, for instance, here on the mass, and I check for instance here, I have a frequency of say 7.5 kHz, which is pretty high for which is not in the range of that 40 to 120 Hz. And now I try to get that motor running again, and for some reason it doesn't want to do that. I can always say that something goes wrong. I think it's a wiring, because these LEDs are not functioning either. And that was some result. Anyway, apart from the wiring to be checked, I found some information on how to adjust the frequency of the pulse width modulation on the Arduino, and this requires coding. So first thing I want to do is get this working again, and as you have seen previously in my videos, the wiring may be improved, and prior to this video I checked this motor, and it worked. So why it doesn't work now, it does. So that is one thing. And now I can measure this frequency once again, and looking at it, it says it is some bit lower, 500, around 500 Hz, but that is still outside the range of 40 to 120 Hz. And when I look at, for instance, this motor here, it's also 400 and around half a kilohertz, 500 Hz, and for this motor it won't be much different. As you can see in the display of the multimeter, it's also some 500 Hz. So it's time for some programming and getting the frequency of the pulse width modulation correct, so I can use that for the speed for the motors. for adjusting the frequency of the pulse width modulation on Arduino. I have looked at a website, at the forum of the Arduino website, where this information has been provided by someone else who needed it. A link to that forum is in my blog on my website. So first of all, I need to do some adjustment in the code, and I will start here, and it is of course from my previous attempt for serial communication, which I've left for now. So I'll start here a new part of the code, and first of all I need to make the PWM buffer clear. Create new eraser variable, and this is the decimal value for the binary 111. And I will put it according to how this everything is officially written. Then the buffer, and yes, this is very technical. And this 2, and don't forget the comments, 2 is meant for pins 9 and 10. So in here I will erase that. Do I not want this, I will have to use another pin. And what I actually do want is, let me check which one that is, quite important of course. I have to look at the circuit for that one motor that is running now. Which is connected to pin 8. And pin 8 is not 2, but it is 4. And that is 6, 7, 8. So that is the one I'm going to change. Then I have to use a so-called prescaler, which actually sets the frequency. And now I have to take care of the frequency itself. It is in a range from 1 to 6, but each number denotes a frequency, and the fischertechnik motors has a range, as already mentioned, between 40 and 120 Hertz, and that means that I have to look at those values. Now 4 is 120 and 5 is 30 Hertz. So what I'm going to do first is use prescaler 4, which is, as said, 120 Hertz. And then another very technical
point, assign the value of the prescaler to the buffer, or register actually. And here and with this the value should be set. So what I'm going to do now is upload, compile and upload, and see what happens. Okay, so far so good, I think. So let's go back to the board, to the circuit, and see what has happened.
So after changing the frequency of the pulse width modulation in software, I have to keep in mind that it's not only pin 8 but also pin 7 and 6 that have been altered. So pin 8, let's follow the wire here, from here, pin 8, yes, going from here and from here to this transistor, driving this motor, and from here also. Anyway, let's measure. So one probe here on the mass, on the ground, that is 500 Hertz, way too high. So let's measure again. Six kilohertz, 2 kilohertz. Let me measure in a different way then. Where goes 7? Here. So measuring the mass and on the resistor, 8 kilohertz, around 4 kilohertz. Wire 6 going right here. That is 120 Hertz. That is 120 Hertz, and that is on wire 6. So that is actually exactly what I want. And what is driving that one? That is this motor. So this motor is exactly at the right frequency. The question is, why aren't the others? So let me measure with, again on the mass, and the other motors. This one is driven from here, 1 kilohertz. The other one is driven from here, also way too high. So right now, once again, this is 120 Hertz, the only one. Now let me turn up this pot meter. totally turned up now, although it doesn't drive the motor yet. So let's see what happens now. Still 120 Hertz. So its programmed is okay. But now I have to look for the other frequencies, because this motor is driving. But if I look for the actual keep things working please, 8 kilohertz. And it doesn't drive anymore, which was not the intention, of course. But that was not the right frequency. So this one has succeeded. The other ones I have to check. Alright, so let's analyze which of the pins 6, 7 and 8 go where. Let me use for simplicity this probe. So let me turn the camera a little bit. So this is pin 6 right here. This leads to here, the orange wire going to the transistor via the resistor, and it drives this motor. Actually this motor under here, this is a switch. So when we measure the voltage on this transistor, it says 14 kilohertz. Measure here, it says 120 hertz. Here it says, of course, 120 hertz. But here it says 15 kilohertz. So the problem may be that although it is recommended to drive a motor through a transistor, as I've done everywhere, it is not driving a motor for pulse width modulation, which is what I like and want to do. So if we check another wire, 7, then we come here for this yellow LED, and I'm measuring right at this point with the LED, and it says 120 Hertz, which is exactly what it should be. However, that has no consequence in working for the motor, because there's no motor involved here. Then let's see for pin 8. Pin 8 goes right here. There are two wires. One, this one following is going to this transistor, but let's check on this pin, and it says way too high, 8 kilohertz. So let me check on this point, 10 kilohertz. Let me check on the other wire, also the same. So that's a bit odd. It is 8 and it is giving a way too high frequency. Check again. So I will conclude from this that this motor won't run because the frequency is way too high. But on the other hand, if it is way too high here, I can't do anything here either. So let's measure this point once again. Well, as you can now see, although the value of that motor here was wrong, this motor has started to run now. Quietly, but surely. So let me and I think that's a nice one. But it is not really explainable to me why that has happened. Well, the LEDs are working nicely, you can see that. But the frequency I need to really actually drive the motor on pulse width modulation, that's not happening. So what I need to do is change this circuit so it doesn't work via the transistor but directly on this motor, and see what happens then. So for just an experiment, and let me point out with the probe again. On this side with the orange wire here, it is 120 Hertz, and this is the line driving the motor through the transistor. So now I'm going to reroute this wire here. So let me do that. Taking it out here, and it stops. And it should actually, but now it is rerouted directly on the motor, and it doesn't work. Let me measure again. Probe on the mass. Probe here. It says nicely 120 Hertz, maybe some more. 120 Hertz, but the motor is not working. So let me check on the voltage. Mass against voltage. It's 4.22 volts. So that does not work. Now I reroute it back to where it was, right here. And the motor responds again, although it's not running right now. But it is powered. So my conclusion is that it is only the the pulse width modulation. I doubt it. However, the voltage should be there. That said, let me measure the total voltage on the system. which is 5 volts, 4.8 volts. So maybe I need to do something about that as well. Yeah, okay, this is a nice development. So the pulse width frequency is correct before the transistor. Transistor moves it way high, but only then the motor works. Interesting. I will have to find out how that further works, and I will do that in the next episode. So for now, thank you for watching, and certainly to be continued.